Hi fourth graders. In this video I'm going to show you how to divide multi-digit whole numbers using partial quotients. So we're going to start with 124 divided by 4. And the nice thing about this strategy is that it is a nice step to long division, which is a strategy that you'll learn in the future. So we set it up with 124 divided by, and sometimes we call this the big 7, because we draw a box around 124 and then a line all the way down. And our divisor goes on the outside. So we have 124 divided by 4. Now, the nice thing about partial quotients is that you can use what you already know. So if you are excellent in multiplying by 10, by 20, by 100, then use that knowledge to solve this division problem. So we need to find a partial quotient that's going to go on the outside of this big 7. And we're looking at 4 times something, and whatever that product is, we're going to subtract it from 124. So that means we couldn't put 100 out here because 4 times 100 would be 400, and we can't take away 400 from 124. 400 is too large. So I always recommend starting with increments of 10. So 10, 20, 30, 40, and if you can get to 100, then use 100. So I'm going to start with 10 just to be safe, and 10 seems like an easy number to multiply for most of my students. So I'm going to start with 10. I put it right outside of the big 7. So 4 times 10 is 40. So I'm going to write 40 here and subtract it. I like to draw a line all the way underneath. That way I know I have a partial quotient for each of my subtraction problems, because the numbers on the outside are what's going to be important at the end. So 4 times 10 is 40, and now I'm going to subtract. Make sure you borrow, because I can already see that the 2 is less than 4, so you're going to have to borrow. So 4 minus 0 would be 4. We would borrow from the 1, make it a 0, and 2 would become a 12. So 12 minus 4 would be 8. So I just wrote down the work that I just said. I borrowed from the 1 to make this a 12, and then I subtracted and got 84. So the nice thing about this is I can keep using 10 as long as the product of 4 times whatever number I put out here is less than 84, you can keep using it. So let's just keep using 10. So 4 times 10 is 40. So 4 times 10 is 40. I subtracted it, drew a line underneath. Now I'm just going to subtract, and it doesn't look like I have to borrow for this one. So 4 minus 0 would be 4. 8 minus 4 will be 4. So we'll have 44. And can I use 10 again? I can, because 4 times 10 would be 40, and that's less than 44. So I'm going to put 10 on the outside, subtract 40, put my line all the way across, and as you notice, there should be a partial quotient in between each of these lines. So now 44 minus 40 will leave us with 4. Now, if I were to put 10 over here, it wouldn't work, because I can't do 4 times 10 is 40. We can't take away 40 from 4. So this leaves us with only one option for a partial quotient, and that's 1. 4 times 1 is 4, and we have 0. So our goal is to get this number down to 0, or a number that's less than our divisor. So now that it's 0, we're done. And now we can just add up the partial quotients. And the partial quotients are all these numbers on the side. So 10 plus 10 plus 10 plus 1. And that will give us our quotient, the answer to this problem. So 10 plus 10 plus 10 is 30, plus 1 is 31. And we always write the answer on top of the box, just like what you would do in long division. So 124 divided by 4 is 31. Now I'm going to show you another way to do the same exact problem, because the nice thing about partial quotients is you can use different partial quotients on the side depending on the multiplication knowledge that you have. So I'm going to set it up the same way. 124 divided by 4. All right, so first looking at this, again, we can't use 100. Like we just said before, because 4 times 100 would be 400. So let's just be safe and use 10. So 4 times 10 is 40. Like we did before, we have to borrow. So we get 84. Now, some students might see this 84 and immediately think of 20. 4 times 20 is 80, and that would just make it so we don't have to subtract as many times. So if I put 20 as our partial quotient this time, 4 times 20 is 80. Look, now it brings us right to 4. So it's less subtracting steps. So, like I said before, now we only have one option for our partial quotient, and that's 1. And we're left with a number that's less than our divisor. It's 0. So now we add up the sides. 10 plus 20 is 30. Plus 1 is 31. So if you notice, we got the same quotient. So it doesn't matter what partial quotients you use on the side, as long as you're following the rules and you're multiplying the divisor by the partial quotient, and this number is less, so you can subtract. It doesn't matter what numbers you use on the outside. So as I was saying before, if your student is really great at multiplying by 5s, try to get them to multiply by 5s, or 50. If they're better at multiplying by 10s, or if they can multiply by 12, use 12. So they can multiply by any number that they're really comfortable with. Now, if they use 10s for really large numbers, it will be a lot of subtracting steps, but they can get to that quotient. Now, the last one I'm going to show you is a division problem with a remainder. So we're going to do 255 divided by 2. So I set it up, 255 divided by 2. So I'm going to choose 100 first because I noticed that there's a 2 in the 100 spot. 2 times 100 would be 200, and that will leave me with 55, so it's not as many subtracting steps. So I'm going to put 100 on the outside. 2 times 100 is 200, and then I'm going to subtract and draw my line across. So 2 times 100 is 200. I'm left with 55. So I can't use 100 again because 200 is too large for 55. So now I'm going to use 20. 2 times 20 is 40, so that's pretty close to 55. So I'm left with 15. And again, your student could have used 10 right there and could have subtracted 20, another 10, subtracted 20 again, and they would have gotten 15 like I did, just in more steps. So with 15, now I can do 2 times 7 because I know that 2 times 7 is 14, and that's very close to 15. And now I have a number down here that is less than my divisor. If I put 1 as a partial quotient, 2 times 1 is 2, and that's too large. So that means I'm done. Once this number is less than our divisor, we're ready to add up our partial quotients. So we're going to add up the numbers on the side. 100 plus 20 plus 7, so that's 127. But now that I don't have 0 at the bottom, this number is important. This number is our remainder. So it's what's left over. So we need to include that into our quotient. And you can either write it as remainder 1, R1, or you can change it into a fraction by putting the remainder over the divisor. So 127 half. So that's how you divide using partial quotients. Remember, it doesn't matter which partial quotients you use on the outside. It will depict how many subtracting steps you have to use. But if your student is comfortable using 10s and 20s and 30s, then let them use that. It'll take more steps, but hopefully they'll become more comfortable with it, and then they can start using hundreds and noticing when it is best to use larger numbers for partial quotients.